Hi students, how are you all? I hope you are all fine. So today I will be discussing with you the derivation for r equals to 2 times f. That means radius of curvature is 2 times the focal length, right? So let's get started. So I will draw first of all the figure here. So let's suppose this is a concave mirror here. Okay, I'm just making concave mirror here. Let's suppose this point is the pole. Right on here, that is the pole of mirror. Let's suppose this point is center of curvature. Okay, and let's suppose I draw one line through this. This is the line. This is called a center. This is center of curvature C. This is pole in between center of curvature and pole. Let's suppose this is focus, right? So, and this line is actually called as principal axis, as we know, principal axis. So now if a ray of light which is parallel to the principal axis, so this is the ray of light which is parallel to the principal axis, after reflection it will go parallel, sorry, it will pass through focus. Let's suppose this is the focus, right? Okay, so that means this is the ray of light which is parallel. If any ray of light which is parallel to the principal axis, after reflection it will pass through focus. This is the simple thing. So what I will do here is I will draw perpendicular at this point. At this point I will draw perpendicular. This is the perpendicular. It will pass through center of curvature. And here this angle is the angle of incidence. And here this is the angle of reflection, right? So if I mark here the point, let's suppose this is the Q point, this is C point, this is F point, and this is the P pole, right? So from the figure it's clear. If I draw from figure, from figure, you can see from the figure angle I equals to angle R. Why it's angle I equals to angle R? As per law of reflection, right? So this is the law, it will never change. So this is the first condition. Second, I can also see as, let's suppose this is the NQ. As you can see, NQ is parallel to CP, right? So this is given there. So NQ is parallel. When these are parallel, that means angle I will be equal to angle, this angle I will just mark in the yellow. This is the angle. Let's suppose this angle is X angle, right? So that means angle X. Why? They are alternate interior angles. Interior angles, right? So these are the two conditions. So we can see from this, let's suppose this is the first or A and this is the second, right? So that means from A and second, from equation A and equation second, what we will get? We get angle I equals to angle R equals to angle X. We can give this name. Let's suppose this is the C here. Clear? So I will draw one box here. I will just put this in the box, right? Okay, so now from the figure, if we'll see the triangle, in triangle QCF, in triangle QCF, angle R equals to angle X. So that means two angles are equal, right? So when two angles are equal in any triangle, we call this angle, oh, sorry, this triangle as isosceles triangle. Isosceles triangle, right? So that means whenever we are having isosceles triangle, so that means their two sides will be equal and two angles will be equal. Obviously two angles are equal, so we will be having two sides will be also definitely equal. So I can just take this side and this side. So that means CF will be definitely equal to the FQ. Mark this as D equation. Clear? Okay, let's proceed further now. So if I will make an assumption here that aperture of mirror is small, aperture of mirror is small. So when aperture is small, that means I will make this mirror, this concave mirror, so much very small, so much small, right? Such that when I will make this small, so this whole mirror will act like this. Let's suppose it's this much small, this is the principal axis and this line. So FQ will coincide with FP. So that means FQ will be equal to FP. So this is the condition number third, and I will write it as equation E. So you can just check from C and D. From C and D, I will write from equation C and from equation C and equation D. Right? What I will get is, you can check from the previous slide as, so we will get, so we will get FP will be equal to PC. Sorry, FP will be equal to, not PC, this is we can say here FC. FP will be equal to FC, right? So I will just write down this equation as F equation. So now from the figure I can from figure I can write this PC equals to FP plus FC. Can I write like this? This is simple. Whole distance I will divide into 2 points, right? So from equation F, we can see F and FP and FC are equal. So I can write PC will be equal to the 2 times FP, which is equal to the PC will be equal to 2 times F, and PC is R. So R equals to 2 times F. So this is the proof for R equals 2 times F, or we can also write in other words F equals to 1 half of R. This was a simple and basic derivation of R equals to 12. Okay, thank you so much.